Today we'll review the procedures for hypothesis testing. As we know, hypothesis is the claim about population proportion or population mean or population standard deviation. We have three parameters of the population that we can test: population proportion, P, population mean, mu, or population standard deviation. Let's first review the procedures or the steps for hypothesis testing. The first step is to identify the claim. The second step is to give the claim in symbolic form. Step 3 is to identify null and alternative hypotheses. Step 4, select the significance level. Step 5, identify the test statistic. And step 6 is to test our hypothesis either with the p-value method or the critical value method. And then step 7, make the decision, and step 8, restate the decision in non-technical terms. So let's review the procedure based on this example. 1,009 consumers were asked if they are comfortable with having drone deliver their purchases, and 54 of them, or 545, responded no. Test the claim that the majority of consumers are not comfortable with the drone deliveries. So let's start with first step, identifying the claim. The claim is that the majority, here is our claim, that the majority of consumers are not comfortable with the drone deliveries. We'll write it in words. The majority of consumers are not comfortable with drone deliveries. Step 2. Now we want to write the claim in symbolic form. Step 2. Write the claim in symbolic form. Symbolic form would be, we're looking at these three parameters and identifying which one of the three we are testing. Are we testing population proportion, population mean, or population standard deviation? Well, since we're talking about the proportion of people who are not happy with the drone deliveries, that means we are testing the claim about the proportion, population proportion P. So population proportion P, we claim that the majority are not happy. What is the majority? Majority is more than 50%. 50% in decimal form is 0.5. So here's our claim. The majority are not happy with the drone deliveries. Step 3. Now we want to identify the null and alternative hypothesis. The null hypothesis, we know, always has an equal sign in it. The alternative hypothesis would be the one that does not have equal sign. The alternative hypothesis has greater, less, or not equal sign. So the opposite of the claim, going back to step 2, the opposite of the claim P greater than 0.5 would be P is less or equal 0.5. Therefore, out of these two claims, our null hypothesis would take the part with the equal sign. P is equal 0.5. Don't worry about the other sign. Alternative hypothesis, since we already used this part, will be our original claim. P is greater than 0.5. Now we want to select the significance level. The significance level is based on, the significance level is our alpha that we want to test. Usually it's 0.05 or 0.01 for the significant put the confidence level 95%, 99%, or it can be 0.02, or it can be 0.1. The most useful is 0.05 or 5%. So that's what we're going to use. We're going to pick the significant level of 0.05. Alpha equal 0.05. Okay. Now, we're moving to identifying the test statistic. When we identify the test statistic that is relevant to our test, let's keep in mind that when we measure population proportion, we use sampling distribution, normal distribution Z. That would be our table A2. And then the requirements is that N times P greater than 5 and NP and Q is greater than 5. And the test statistic is used Z. When we test the claim about population mean, that we're using the T distribution. And the requirements is that sigma, when sigma is not known, and normally distributed population, or sigma not known and sample size is greater than 30. Then we use T statistic. When we test the population mean and sigma is known and the population is normally distributed and sigma is known and the population size is greater than 30, then we use Z statistic. When we test a claim about standard deviation or the claim about variance, we use chi-square distribution, and that has a very strict requirement of normally distributed population, and we use chi-square distribution. So we identify the test statistic. We're going to be using Z. The formula to find Z is P hat minus P divided by the square root of P times Q divided by N. So let's identify what was our P hat. P hat is a sample proportion, which is X over N. X is 545, N is 1009, and that will give us 0.54, which is already identified here, 54% or 0.54. The P is our population proportion, which is in this case, we're testing the claim that the majority of consumers, so P is 0.5, Q is 1 minus 0.5, which is also 0.5 in this case, and N is 1009. So let's find our Z value. Z is equal to P hat, which is 0.54, minus P, 0.5, divided by square root of 0.5 times 0.5 for Q, divided by 1009, equal to, then I'm going to use the calculator to simplify this value. So we found that our Z, our test statistic is 2.54 rounded, or if we do it on the calculator or any other technology, we'll get 2.55. We'll consider it 2Z equals 2.54. Now, what is the test statistic? The test statistic, in this case Z, is a value used in making decision about the null hypothesis. It is found by converting the sample statistic into a Z-score. A sample statistic P hat in this case, or X bar if we're talking about mean, or S